Hello, Otsuchi Wademba, and in this video, we'll be solving the problem 24 from the NMC first round. So I given a diagram and told that AB is 30, BC is 20, and asked to find R, the radius of the circle centered at B. So before we dive into the solution proper, let's establish a common knowledge about tangent circles. So when you have two tangent circles, right? There's always a line that is tangent to both circles at that point of tangency. Now, from the first center of the first circle, let's say C1, the radius to that point is going to meet that line at 90 degrees, of course, because it's tangent to the first circle. And then the radius from the center of the second circle, C2, is going to meet that line again at 90 degrees as well, because that line is tangent to it as well. So what does this mean? This means that C1, C2, and the point of tangency, let's call it T, all lie on the same line. Another thing we can establish by symmetry is the point where the lines that are tangent to both circles meet. Let's call that point P. Now, P also lies on this line. So we get that P, T, C1, and C2 all lie on the same line. So now let's import that into our problem. Now, from this, we can get that BC, this point, the point of tangency between the circle centered as P and C, and then the point, let's call this point P, mean together they all lie on the same line from that. And then we also get that BA and the points where they meet and this point here all lie on the same line as well. So that means all these points all lie on one line. So that's one line. They're joining P, A, B, and C. And then of course we have the radius to this point here meeting at 90 degrees and the radius to this point here meeting at 90 degrees because they're tangents. All right. Now we have that the radius of the circle centered as B is R. So here will be R. And here will be R as well. Also, we have that AB is 30. So here is going to be 30 minus R. And because it's a radius, here is going to be 30 minus R as well. And then we have that BC is 20. So here is 20 minus R and here is 20 minus R. Now, all these lines are let's call this points TC, TB, and TA. So now triangles PTA, PTAA is similar to triangle PTB, and similar to triangle PTC. See, right? So those three triangles are similar, right? Because their angles are all the same. We have 90 degrees, 90 degrees, 90 degrees. We have this angle here as well. So that's enough to establish similarity. So from that, we can get that CTC all over BTB is equal to BTB over ATA. Right? So this is going to imply that 20 minus R over R is equal to R over 30 minus R, and then this is going to imply that R squared is equal to 20 minus R times 30 minus R, which is equal to R squared minus 50R plus 600. So R squared goes with R squared, and this is going to imply that 50R is equal to 600, which implies that R is equal to 600 over 50. And that gives us 12. So 12 is our answer. And then the solution to this problem is, the answer to this problem is option C, 12. Thank you for viewing. We'll see you in the next video.